Welcome back. This is part 2 of absolute value inequalities. I hope you had a good learning check. Did you look over your notes? Do you remember what we did? Now let's keep going with part 2. So here we have another absolute value function, and in order to do this we need to isolate our variable. So I will walk you through those steps. As if this were a regular equation, but the first thing we need to do is get that absolute value by itself. So then we can start working on the variable. And the first thing I see is this plus 12. To get that absolute value by itself, I'm going to do the opposite. The opposite in this case is subtract 12. Whatever you do to one side, got to do to the other side. So over here is a Sorry, I got a little excited about that. 10 minus 12 is negative 2. And this is gone, so then we have 3 times the absolute value of 2x plus 9. Is our absolute value all by itself yet? Nope. So we have to do the opposite again. Now when this number 3 is outside the absolute value, it's assumed that that is multiplication. So 3 times all that stuff, the opposite of that is just going to be dividing by 3. Whatever we do on one side, have to do to the other. So what we get now is a hua. That'll leave us with the absolute value of 2x plus 9 is equal to negative 2/3. Now at this point we can think the absolute value, remember that's the distance from 0 on a number line. And since distance can't be negative, it doesn't make sense, an absolute value can never be negative. So looking at our equation, we have something where an absolute value equals to negative 2/3. Is that possible? If you can spot this soon enough, because the absolute value is all by itself, and the other side of the equation is negative, you can just say no solution. Now you might have tried to do more work with it, but once you have the absolute value by itself and the other side is negative, you know that there's not going to be an answer that will ever get this absolute value to be a negative. In our next example, we see that this is no longer an absolute value equation, it's an absolute value inequality. So we're going to solve it almost as if it were an equation. We're going to look at two different options. One where it's the positive, where we're kind of ignoring the absolute value, so it's just like this. And then we're also going to look at what it would look like if you had a negative on the opposite side. Now there is something when we deal with inequalities called the special rule that says when you are checking for, when you're solving an inequality and you have to multiply or divide by a negative number, you flip the sign. Well, if we're going to look at the opposite side, so there's a 5 on one side and we're looking at a negative side, well, guess what has to happen? That sign is also going to get flipped. Even though they're in the same direction, you remember we want to look at it in regards to the W. This W minus 21 was less than 5, and now it's greater than negative 5. So it's almost like it becomes a compound inequality. Once you're here, though, you can solve this just like it were a variable party with lots of numbers and a lot going on. Starting with here, I would add 21 to both this side and this side. Here we'd get a hua, hua, hua. You weren't ready for that one that time, were you? So we get W is less than 5 plus 21 is 26. And negative 5 plus 21, sign's not the same, so I'm going to subtract, and I get 16. Alright, at this point, yes, you could graph it, which I will do on the next slide, because we have a graph. So again, we simplified this. This was not negative. This was 16 is less than or equal to W, which is less than or equal to 26. So I'm going to add a 0. Here's 16. Here's 26. W is in between. These are equal to signs underneath, so these are going to be closed circles on the 16, closed circle on the 21. W is greater than 16, so it goes this way. W is less than 26, so it goes this way, and we shade in between. This is an AND, or of course an intersection inequality. So there's your graph. Pause it if you need to at this time. Time for a learning check. Go back, look at your notes, think about some of the stuff we did. What do you do when you have absolute value in an equation? What do you do when you have an absolute value in an inequality? I don't know. Look at your notes, see what we did. If you're standing next to someone, ask them that question, see if they know. Now it's your turn to work on these problems. Make sure you actually do it. Don't just wait till I put the answer up. You have to actually work the problems. So, hit pause. You didn't hit pause, did you? If you do that again, something bad's going to happen. Don't make me tell mama jokes. You didn't hit pause? Alright. Your mama's so ugly, the toll booth operator pays her money to drive faster through the toll. Now that's ugly. Your mama's so dumb, on Halloween, she wanted to dress up like the Invisible Man, but didn't know what he looked like. Now that's dumb. Alright, so here's your last chance. Hit pause. Because after this, I'm just putting up answers. I'm not going to explain, because you should be working these on your own. So as you can see, the solution to the first problem has two answers. Again, absolute value, 2 bars, 2 answers. Now, you can look at the steps of what we did. We had to isolate the absolute value symbol. And then we wanted to get the variable by itself in both cases. First one where as if the absolute value is not even there. Second case as if the absolute value is equal to the opposite of whatever's on the other side. In this case 3, so it became -3. So if you solve that, you get two solutions, x equals 6 and x equals 0. Next, work on the second problem. Hit pause, because again, I'm just putting up the answer. So as you can see, we solved this like it's a compound inequality with a side where it's equal to the opposite of whatever's on the other side of the absolute value. And when we solve this, we get the range of values x negative 2.4 is greater than or equal to x, which is greater than or equal to 4. Alright, so these are the two examples I hope that you can explain. Make sure you know how to do those. If you have any questions, bring them to class tomorrow. Which is, of course, baby pictures from my favorite period. You know which period you are. Oh yes, that's what you look like as children. Oh, so cute. Or should I try to scare you again? No, okay. Nothing scary this time. But what I would like you to do, this is it, just summarize your notes. We will talk about those in class. Again, summarizing something about absolute value, something about how to solve them, what happens with inequalities with the absolute value, and anything else that you did. Just show me 2-3 sentences. I will check these notes in class. Hope you had a fun time. I'll talk to you later.